Okay, guys, here we go. So for chapter 7-4, we're going to try to decompose 5x minus 66, okay, over 2x squared minus 7x, okay, and minus 15. Okay, so we got to make sure this is a proper fraction. In other words, the numerator has a power that's less than the denominator. So that's how we know this is proper. Okay, so first thing we have to do is take this guy and factor it. Okay, we have to always be able to factor the denominator. So we got to factor 2x squared minus 7x minus 15. Okay, so this first example, I'm going to break it all down for you. You should know how to factor this by now, but in case you forgot, here we go. Negative 15, okay, times 2, negative 30. If you remember, negative 15 times 2, okay? The middle number is negative 7. So we're looking for two numbers that multiplies to be negative 30, adds to be negative 7, okay? So we're looking at negative 10 and 3. So remember how to factor. It's 2x squared minus 10x plus 3x minus 15. First two, they have a 2x in common. You get x minus 5. Last two, they have a 3 in common. You get x minus 5 again. These two always have to be the same. So because they're the same, we're going to cross it out and factor that out. X minus 5 and 2x plus 3. There's different ways to factor, but this is the way I like to do it. Okay, so it doesn't matter how you factor it, it's up to you. So now I have my two denominators. Okay, I'm going to try to break this fraction down to two fractions. My first fraction is going to be x minus 5 on the bottom. My second fraction is going to be 2x plus 3 on the bottom. Okay, so I'm going to put here a on top and b on the second fraction. Okay, so far I took this fraction, I broke it down to two other fractions. But now what I need to know is what's a, what's b. Okay, so now if you remember, we're gonna try to play jealous neighbors, right? We're gonna cross multiply these. Okay, so if you remember, it's negative 5x minus 66 over 2x squared minus 7x minus 15, okay, equals a over x minus 5. And then b over 2x plus 3. Now, to make my denominator, before I add the fractions, I have to make the denominator the same. So this first fraction needs 2x plus 3 on the bottom and on top, 2x plus 3. And on the second fraction, okay, in order to make the denominator the same, this guy, b here, needs an x minus 5 on the bottom and on top. Okay, so now, if you notice, my denominator on all three fractions is the same. It's just this guy has been FOILed out. 2x squared minus 7x minus 15 is x minus 5, 2x plus 3. And it's the same thing if I put them backwards, 2x plus 3, x minus 5. So what does that mean? Well, my denominators all match. They're the same. So for now, I'm just going to ignore it. I'm just going to focus on my numerator. Negative 5x minus 66. My denominators are all the same, so I'm going to ignore it for a moment. Equals a times 2x plus 3. Once I make the denominator the same, that allows me to ignore it and focus on solving for what's b and what's a. There we go. So now I have this linear, no more fractions, okay? Linear system, okay? So what I want to do is distribute a, distribute b. So negative 5x minus 66 equals 2ax plus 3a, okay? And then plus bx minus 5b. Now, if you notice, I'm going to combine like terms. These two guys have x's. These two do not have x's. Okay, so negative 5x minus 66 equals, okay, these two have x's involved right here. So it's 2a plus b parentheses x. All right, I'm just gonna take the x away from this guy and x away from this guy. There it is, 2a plus bx. And then the other two terms, they don't have an x at all. So it's just 3a minus 5b. Okay, so what that tells us is we played the matching game right here. These two must equal. So negative 5 must equal this term over here. Negative 5x must equal this guy, x. So negative 5 must equal 2a plus b. My constant is negative 66. Okay, it doesn't have an x. These two terms don't have an x. So these two, negative 66 must equal these two, 3a minus 5b. So now what I did is I have a system of equation now, and I need to try to solve this. Okay, so now if you look at this system is easily solved if I multiply this guy by 5. Okay, if I do that, I get negative 25 equals 10a plus 5b. My bottom equation, I don't have to do anything with. I just leave it alone. I get 3a minus 5b. Now I'm gonna add these guys. I get negative 91 equals 13a. What happens to the b's here, right? The b's go away. So that means I can solve for a. I'm gonna divide by 13. Negative 7 equals a. Perfect, right there. A is negative 7. Okay, now I'm gonna go back up here and I'm gonna I can do a couple of things. Okay, I can substitute it, or I can do elimination, okay, and get b. But the easiest way I found is just to substitute a in there. So first equation says negative 5 equals 2 times a. I found a. A is negative 7 plus b. Okay, so negative 5 equals negative 14 plus b. Bring that over, I get 9 equals b. There you go. Now that you found a, now that you found b, doesn't mean you're done. You have to put it in the right place. So originally, remember, is negative 5x minus 66 over 2x squared minus 7x minus 15, right? Equals. Now look up there. Okay, when we broke it down originally, we said a over x minus 5. Well, a is negative 7. Okay, a over x minus 5. A we found is negative 7. Look up here. This says b over 2x plus 3. And what is b? B is 9 over 2x plus 3. There's my answer. Okay, so what I did was I took the original problem, which was a fraction, and I broke it down to the addition of two smaller fractions. And if you want to check this, okay, you want to check this, all you got to do is cross multiply them. What I mean by this is to check, okay? If you want to, you can check. You can check by cross multiplying. Cross multiply, okay? In other words, negative 7 times 2x plus 3, and then 9 times x minus 5. I get negative 14x minus 21, 9x minus 45. Combine like terms, I get negative 5x minus 66, which I had over here. Okay, so this is just my checking method. But here's my answer, okay? All right. We can do another problem. Sure, no problem at all. Let's go with another example. Okay, we can do another example here. So we'll do another linear example. Negative 2x plus 43 all over 6x squared plus 17x minus 14. Okay, so let me slide this up. Okay, so remember, first thing we did there was we had to factor. Okay, we got to factor this guy. So I'm not going to go through the whole process, but you need to be able to factor this, okay? So I'm going to put an A up here. If you factor this properly, it's going to be 3x minus 2. And put a b up here. The second factor is going to be 2x minus 7. Okay, so when you factor, you should get these two right here. Now, your job is to find out, hey, what's a? What's b? All right, so negative 2x plus 43, 6x squared plus 17x minus 14 equals a over 3x minus 2 plus b over 2x minus 7. Okay, let's play some jealous neighbors. Okay, looking at these two. Okay, this is actually 2x plus 7. I'm sorry about that. Okay, 3x minus 2, 2x plus 7. So, looking at these two denominators, okay, if you wanted to make them the same, you would have to multiply the first fraction by 2x plus 7, top and bottom. And you would have to multiply the second fraction, top and bottom, by 3x minus 2. 3x minus 2. Okay, so now what we notice is that all three denominators, denominator 1, denominator 2, denominator 3, they're all the same. Because they're the same, we can just ignore them. Okay, so in my next step, I'm just going to ignore them. We're just going to focus on the numerator. Okay, so I get a 2x plus 7, b 3x minus 2. And again, let's distribute. Negative 2x plus 43 equals 2ax plus 7a. Okay, now if I want to, I can distribute here. Okay, but if I want to, I can put this right here, 3bx, under this guy. So 3bx. When I distribute, I get 3bx. Okay, when I distribute, I get negative 2b. What I'm doing is I'm just trying to organize it a little bit. Okay, so what do you notice about this guy? These two right here have an x. That has an x. So I'm going to match it up with these two. Okay, so negative 2 must, negative 2x must equal, okay, 2a plus 3b x. Notice that, right? If I add these together, I get this. So now they have x's right there. So let me ignore the x's. I'm going to focus on negative 2 equals 2a plus 3b. Now, next comes the constant, 43. 43 equals these two guys because these two don't have a x. So 43 must equal to 7a minus 2b. Okay, so now I have a system of equations with these two right here. First one is negative 2, 2a plus 3b. And my second one is 43 equals 7a minus 2b. I'm going to try to solve this system of equations. Okay, so in order to do that, I'm going to multiply the top by 3, bottom by 2 to make the b's opposites. So multiply everything here by 3. 129 equals 21a minus 6b. Multiply bottom by 2. Negative 4 equals 4a plus 6b. Add them. When we add them, we get 125 equals 21a. What happens to my b's here? B's, they go away, right? Nope, 25a, sorry. So that means a equals 5. I found what a was. Okay, so now I can take a, which was 5, and plug it into either equation. The bottom one looks a little bit better because smaller numbers and stuff, but here we go. Negative 2 equals 2 times 5 plus 3b. Bring this over. Negative 12 equals 3b. That means b equals negative 4. Now we found a and b. So now look up here. A, where was a? When you originally set up the problem, a is above 3x minus 2. So negative 2x plus 43 all over 6x squared plus 17x minus 14 equals a over 3x minus 2. So 5 over 3x minus 2. And then here I found b. So plus, if you want to do plus, you can put negative 4 over 2x plus 7. So here's my answer. What we did was we took the original fraction and we broke it down to two smaller fractions. That's the idea. Okay, we are decomposing. Okay, decomposing. That means, hey, break it down. Okay, all right. Have fun with your other problems.